Hi everyone, good morning. My name is Tina and I work in Opera. Like in Opera for desktops, we have built-in feature for blocking ads and trackers. To turn it on, you can click an icon in address bar. You will see this arrow some pop up. You also can manage this built-in feature from settings where you can add some recommended lists or even some custom ones. But that's not all that you can do. Because it's deeply integrated into the browser core functionalities, testing such kind of built-in feature, it's quite different than testing an extension, like a little bit. So this integration, it gives us greater control and flexibility, but also it also brings some unique challenges. So today I'd like to share with you how we test built-in Adblocker in Opera. I'll show you challenges we've overcome and lessons we learned along this way. So let's dive into it. The backbone of our testing strategy, like it's unit tests, no surprise here. So we need to make sure that every small key part of our feature that works perfectly before we move to some broader tests. What do we check here? So first of all, we have some cache tests. So we check how rules are stored. We also have tests like for checking some rule management tests for check life cycle of the rules, how they are enabling, disabling, how they're removing, adding. So these unit tests are so critical that if they fail, it can be a strong argument for us to delay the whole browser release process. Next up, it's important for us how a blocking feature looks and feels. So UI testing, it's also one of the milestones. Because it's integrated deeply, as I said, like into the browser, it's featured both native and web UI components. So we want to make sure that it looks good no matter if you use a dark or light theme, or maybe you're a user of multiple displays with different resolutions, or you're a touch screen user, or you're going onto different operating systems like Windows, Mac, or Linux, whatever. So we want to get sure that it looks good and similarly on all of them. Another type of test that we conduct, and they're quite special, like they're quite specific for browsers. We call them browser tests. What we test there, we check that ad blocking works smoothly with some site-specific rules, that your trackers identified correctly. We also have some tests that check that your custom rules are effective and that whitelisted sites, that they remain unblocked. And of course, automated tests. Here we make sure that Adblocker fetched and applies updated rules. We check for issues like failed updates or unavailable server, and ensure that system fall back to the previous version if needed. Plus, we run some linting and schema validation tests there to catch errors earlier in a cycle. Okay, so all those four types of tests, they are very important and they are like a core of the strategy. But let's say real world test, it's a bit different story. So real world conditions also very important. And as part of our ongoing quality assurance process, we run periodic integration tests that, like for example, we use easy list and easy privacy there. So this gives us an extra layer to make sure our product performs closer to authentic user experience. So such real-world tests. We use the most recent Adblocker and Tracker Blocker release there, and we test them directly on live websites. to simulate how user experience the product. So we apply here, of course, some standard tools like a snapshot testing or, for example, adaptive scripts, but it doesn't work in every case. And these tests, they become unreliable easily due to constantly change web content and ads. And they are hard to maintenance and they require significant tester resources to make them reliable. So the idea was to bridge somehow this gap and build a stronger and more reliable testing strategy that turn into real world use, not just to simulate lab conditions. Okay, so here, like one of the challenges that we hit with this kind of testing is dealing with the variability of A/B tests that different portal use. So the most popular example is geo-targeted issue. Like, for example, here, like this test failed because server denied access. But when we dug deeper into it and we dug into some regression change log, we ran some isolated mocked up tests, we didn't find any obvious root cause this regression within our code. So sometimes it can be even trickier because website can load itself correctly, but some part of the website, like the block under the header or some part over the footer or sidebar, like may flag some problems with availability. So what is the usual fix there? Like usually we apply some retry logic, and if it doesn't work, we put this flag here test into the quarantine. But this can significantly reduce the test coverage and may result in missed bugs and regressions. Plus, we are looking for ways to speed up this whole process of identifying this core. Why the core of the problem? Why this test failed a little bit? So to tackle these challenges, so here's an AI part, like continue this topic of 2024. To tackle these challenges, we took a different approach. We decided to leverage some of the tools already available for our customer support teams. So we bring them into our testing cycles and into our automated testing framework. To centralize user feedback efficiently, we firstly have to gather all feedback in one place. So we took all feedback from surveys, from blogs, from customer support portals, like whatever, and we bring it together in one place. Then we clustered and categorized the entire data set. And we found a cluster that connected to blocking ads and trackers. So by analyzing this cluster, we uncovered some detailed categories and we also get some insights. And this helps us refine tests and identify gaps in our previous testing coverage. So this approach makes us sure that our test reflects what users actually experience. We can also set up some alerts to notify us, to tell us when something we test, when it's also mentioned in user feedback. So let's maybe see some text, some examples. So here we have a site, block of ads. It's not fully hidden. It's one of the famous magazine website, and it's show you a different layout depending on user location. So it's a classical example of geo-sensitive flaky test. Normally, this test would just fail. Then if it doesn't work, it will go to quarantine. But when after this integration of user feedback into the framework, we started getting alerts when users in specific regions, such as Asia, for example, when they also experience or they report the similar problems as our test executives encountered. On these reports, let's say users can describe their problem in different ways, of course, use different languages, but we saw the spike in our reports, and we can identify that all of them connected to the same core. So how it works a little bit from inside. The system, it labels tests as flaky due to some external reason. So we can significantly reduce the time spent, testers spent on identifying, on analyzing these failures. It's also helped us with rerun such kind of labeled tests, because now, if we see that this failure is come from Asia, we and users also report the similar problem in, let's say, they declared their location in Asia, we can reassign this test from the framework and run it, let's say, in Latin America. And then, if this test passed, we know that, okay, it's definitely a geosensitive flaky test. We save this information in our history. So this kind of approach, it works not only because I talk a lot about geosensitive flaky tests, it works not only with them, it also works when, for example, A/B tests like Portal have A/B tests on device types or operating system or user agent string. So it works there also. It also can work vice versa. Like when we got some spike in reports that user reported, let's say, Adblocker stopped works on some website, we can dive deeper into it, we can analyze it, coach it, and then we cover it in automated tests. Another tricky example that can confuse both users and testers, it's when the core website functionality get blocked by mistake. So another example from YouTube, for example. Here we have user get information that there is no internet connection. And of course, can be tricky for tester, but it's more confusing for users, because user might start troubleshooting their network, not realizing that it's actually Adblocker list causes problem or something like it. So this kind of issue, they often involve a unique mix of factors, some corner cases that fall outside of our standard testing scenarios, that fall outside of our smoke test list. But with user report in this loop, we can replicate the situations and expand our automation tests to better coach such kind of errors earlier. Okay, so in wrapping up, I hope I give you some glimpse into how this automation testing strategy works in Opera, how we test Adblocker, perhaps offered you some inspiration how to test also. On this screen, you'll see our customer support portal, one of the key communication channels actually that we use, that you can report if you have any bugs, you can report it from Opera Menu and click report the issue, you're welcomed. So here I want to emphasize that feedback, building this bridge between users community and testers and developers, it's very important that feedback, it's also essential for us testers, because it helps us to identify such real-world issues that may not surface during our some internal testing. And this allows us also to understand some, to prioritize flaky tests, to prioritize some failed tests, to better address some specific or some corner cases. Because our goal is to continue enhancing the browser experience by providing reliable and effective adblocking solution. So thank you for joining me today. I look for questions or thoughts you'd like to share.